Hello everyone, I'm Frank and welcome to Frank Puzzles. And this is today's very hard puzzle. And it's called Death Spiral by Andrew Sarkis. And hopefully we don't get into a death spiral of our own trying to solve this puzzle. Anyways, let's get to the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. We have a region sum line, which is blue. They both look kind of blue, but I guess one is considered teal. Anyways, region sum lines work like this. Box borders divide the region sum line into segments with equal sums. So the sum of these digits must equal the same sum as these digits, which must equal the same sum as these digits, which must equal the same sum as these digits, which must equal the same sum as these. Basically, all these segments must equal the same sum. So that should tell you something there. And that's how region sum lines work. We also have, and this is the only other rule here, we have modular lines, which are the teal lines. And any run of 3 sequential cells on a modular line must contain one digit from each of the sets 147, 258, or 369, which is the equivalent of 1 mod 3, the digits that when divided by 3 give you a remainder of 1, 2 mod 3, which is the digits when divided by 3 give you a remainder of 2, and 0 mod 3, which when divided by 3, the digits when divided by 3 give you a remainder of 0, right? So 1, 4, and 7 when divided by 3 give you a remainder of 1. 2, 5, 8 when divided by 3 give you a remainder of 2. And 3, 6, 9 when divided by 3 give you a remainder of 0, which is why it's called a modular line. So in any 3-run segment on these modular lines, you have to have 1 from 1 mod 3, 1 from 2 mod 3, and 1 from 0 mod 3. So you could have something like along the lines of 5, 9, and 7. And this would be valid because on this stretch of 3 digits along the modular line, we have 1 from 1 mod 3, 7, 1 from 2 mod 3, 5, and 1 from 0 mod 3, 9. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so I guess we should color this long modular line. We'll just mark it green, pink, and orange. So green, pink, orange. So that's every third. Green. So those are green. We have pink. And orange. Okay. Well, in column 1, we are guaranteed 3 greens, which means none of the rest of the column is green. So this can't be green, so therefore this must be the green modulo set, and this must be pink and orange as a set here. One of each, which gives us 3 pinks in column 1, so this must be orange here. Okay. We know we don't have very much else. Okay, this interesting. We have 2 greens in columns 4 and 7, where a modular line is. So that means we are guaranteed a green in this set of 3 for these modular lines, which eliminates green from the remaining. And these can't be orange. Well, one of them can be orange. That's it. Huh. Okay, we don't really have that much information. We do know one green is here, one green is here. The rest of the column cannot be green. So this is pink or orange here. This is pink or orange here. So we have one green here. What else do we have? We don't really have that much information. We do know these add up to, well, 15 at least. The interesting thing, well, they can't be 15. If it's 15, that means this is 15, this is 15, and these 3 must add up to 15, but these 3 also add up to 15 because they have 15 here, 15 here. These 2 digits are the same, so these 2 digits have to be the same, which is obviously incorrect. So it cannot add up to 15 here. It's at least 16 then. So the sum of all these digits are at least 16. What's the max sum you can have? So the minimum sum of the region sum line segment is 16. The max, you could have the digits 2 through 9 here, and then another 9 there. That's the maximum possible, and then divided by 3. 2 through 9 is 44, plus 9 is 53, but that's not divisible by 3. So it has to be 51? Right, which means this is either adding up to 16 or 17. 51 divided by 3 is 17, and obviously you could have 48 divided by 3. Okay. So this is 16 or 17. If it's 17, it cannot be 1, 2, 3, 4, 7. Because you would eliminate 1, 4, and 7 from the rest of this box, and we have to have one digit from 1, 4, 7 on this modulo line, right? Because one of them has to be 1 mod 3. So if it's 16, if it adds up to 16, it's 1, 2, 3, 4, 6. If it's 17, it must be 1, 2, 3, 5, and 6. So either way, this is guaranteed to be 1, 2, 3, and 6. And we have either 4 or 5 here. Which means this is then 4, 5, 7, 8, 9, because 1, 2, 3, and 6 are guaranteed to be on this region sum line. 9 has to be the odd digit here, so this cannot be, or the 0 mod 3 digit here. So this is guaranteed to be 9, therefore 9 cannot be there. So what does that mean? Particularly, how does that interact with row 2? If we had we are losing, this has to be green. Because we are losing, so this sum is equal to 45, which is divisible by 3 because you have 0 mod 3. If you remove a digit from that's 0 mod 3, this still has to be divisible by 3 because they are the same, they add up to the same sum. And therefore, this must be the same modulo 3 as this. So this has to be green here. Because we're losing the same modulo, right? So if you go to 48 to 51, or sorry, 45 to 48, this has to have a difference of 3, which is the same modulo 3, no matter what you have. This, if you go from 45 to 51, then you still have to have the same modulo 3. So this has to be green no matter what. This is obviously pink and orange as a pair. We don't know which. Which means this can't be green. This is orange or pink, which means we need, 2 more greens. Never mind. Because we have a green here. Okay. We are losing in this column a pink and an orange. And we must have a pink and an orange corresponding here. But we don't necessarily know if those are the same, right? So the difference, so this digit must be smaller than this one. And it has to be smaller by 3 at least. So this is 4 through 9 here, and this is 1 through 6 there. Interesting. Does that help? I don't know. This is 4 digits adding up to 16 or 17. Huh. Hmm. At least one of these is green, because you can't have 2 greens here. So at least one of these is green, but that doesn't really tell us much. Okay. Um, hmm. This is the same as that. Does that tell us anything? Not particularly. One of these could be orange, so we cannot eliminate orange from both. Huh. Oh. Huh. Can this be orange and pink there? And I think the answer is no. If you have orange and pink, that's one mod 3. You have one of each set here then. One would be orange and pink, and then you'd have a green. So that would guarantee 1 mod 3 plus 2 mod 3 plus 0 mod 3, which means they are adding up to a sum that will be 0 mod 3, right? Remainder of 1 plus remainder of 2 gives you 3, which is divisible by 3. So this cannot be the same set here, because then that would be giving you a 0 mod 3 sum, which 16 and 17 both are not. So this has to be the same set. Cannot be pink, so this must both be orange. Therefore, that eliminates orange from the rest of the region. This is orange. This can't be orange, so this is pink here. This cannot be, we don't have any more oranges in row 2, and we can't have green and pink here for the same reasoning here, because then they would be the 0 mod 3 sum, which 15, 16, and 17 cannot be. So this cannot be green and pink here. It must be 2 pinks, which means this can't be pink. This is orange, which means this can't be orange. It's pink. Remaining digit in box 1 has to be green. This must be 2 greens now here. So we have 2 pinks, 2 greens, and 2 oranges, all summing up to the number. Can it be 16 is the question. So these have to be pink and orange. Here we're missing an orange here in this column, and we are gaining an orange back on this sum. So we were missing a pink here now, which means we must be missing a pink back here. So this is pink here. And this cannot be a set of orange and green. So we need a pink here. So we're guaranteed a pink here. We have 2 pinks here, which eliminates pink in the rest of the column. So this can't be pink, that's orange. We have 2 oranges there. This has to be 2 pinks in this set, because otherwise it would be 1 each. If it's not, this is 1 each of orange and green, which again would add up to a 0 mod 3 sum, which is not allowed. Can you ever add up to 16? So you would have 0, 0, 1 mod 3 to add up to 16. 0, 0, 1 mod 3. 1, 1 would have to be with 2 mod 3. And 2, 2 would have to be with 0 mod 3. So that could work either way. So that's fine. This is pink or orange. This cannot have 2 oranges. This has to have a pink here. So we have 1 pink here. That guarantees 1 pink here. So this is orange or green. One of these is pink. So that means we're guaranteed a pink here. Well, again, you can't have orange, green, and pink in the same sum because that would add up to 0 mod 3. So we're guaranteed a pink here. If we had only one orange and one green, that doesn't work because that doesn't add up to 0, non-zero mod 3. So this has to be 2 greens and a pink. So this is 2 greens and a pink here, which means we have an orange in one of these, which means this cannot be orange. This is green, this is pink and orange here. And this must be then orange and pink here. So this is orange or pink here, not green. We have 2 greens here and 1 pink. So that's going to be the same for this set, right? We cannot have more than 1 pink here. This is at most 1 orange. We cannot have 2 oranges here. So this is either, it can't have 2 pinks here. This must be double green. So this cannot be green. This has to be orange or pink. We have orange and pink here, orange and pink here, orange or pink here, orange or pink, orange here. So that means we only have 1 more orange or pink for this set, which means one of these is guaranteed to be green. So we have a green here with orange or pink, which leaves this as green here. This is then, one of these is green with orange or pink, and we have orange or pink here. Okay. This is green. So we have 1 green here, we have 1 green here. Obviously, this can't be double green here. This cannot be double pink here because of the 2 pinks in the row. So this must be double orange. So we have 2 oranges and a green here, which eliminates orange from the rest of the box. So this cannot be orange. Therefore, this is pink. This must be a no orange. So this is orange here. This is pink, which makes this not pink, or not orange, that's pink. Not pink here, that's orange. One of these is pink. This is pink, that's pink. That's 3 pinks in row 5. This cannot be pink, therefore it's green. We have 3 greens now in row 5, so the rest are orange. So these are all orange. This cannot be double orange. This is green, and we don't know what the other color is. This is orange, orange. This is green. We have pink, pink there. Okay. Hmm. Where are the oranges in column 2? We can only have one more orange here. And, well, okay, never mind. Um, hmm. Never mind. Hmm. This we don't have any information about, so that's not going to be helpful. Hmm. We are missing a green here, which means that's going to be the same change in, that's going to be no change in modularity. So we must be losing the same modularity here. So this cannot be orange, it's pink, which means this can't be pink. This pink eliminates pink here, so that's orange, which means we don't have double orange here. This is green and pink. Orange here, orange here, orange here means the rest cannot be orange. So this is green and pink as a pair. Only one pink is here, at most. So this is pink here, that's pink here. We have orange here. Okay. This is orange, that's orange. This we don't know what that is. It's either 1 mod 3 or 2 or yeah, it's either 1 mod 3 or 2 mod 3. We don't know which one though. Um hmm. We know one of these is orange. That's for certain. But that's it. We don't know the other one. Um hmm. Huh. One of these is orange, but we don't know which. We don't have any information about the green and the pink either. Hmm. Hmm. Um. Hmm. What else do we have? Hmm. Um. Hmm. Hmm. Okay. So on this line, we can only have at most one pink. I don't know if that tells us anything. To add up to 16 or 17. 16 with 4 digits. Could be a wide variety. You could have 1, 2, 4, 9. Um, hmm. Hmm. Can we ever have like a 9 in one of these cells, is what I'm thinking, right? In one of these cells that are not on the region sum lines, can we have the largest digits? Because we have to make up for... I mean, technically, if you're losing a 9, well, maybe. So we have 2 orange and a green there. 2 orange and a green here. 2 greens and a pink here. 2 greens and a pink here. 2 pinks and a red here, orange here. 2 pinks and orange here. And this is also 2 greens and a pink here. Do they have to be the same ones? Maybe. $17. Okay, so how do we add up to 17 with the different modulos? For double 1 mod 3, you can't have 1 4. You have to have 1 7 or 4 7. Right? So 1 7 and 8. Oh, 1 7 and 9 add up to 17. 4 7 and 6 add up to 17. Let's write these down. So 179 or 476 add up to 17 for 1 mod 3. Double 2 mod 3. 259. You can't have. You could have 5. Okay, so 259. No. 2-5 doesn't work. 2-8-7 works, or 5-4-7 works also for 17. No, it's not 4-5-7. It's 5-8-7. No, 4-5-8. Ugh. I'm miscalculating there. That's weird. Okay, so for 17, it's 179, 467, 278, 458. For 0 mod 3, it's what? Cannot be 3-6. Actually, it could be 3-6. It can't be... No, it can't be 3-6. No, 3-6-8 works. So you have 3 of them, I think. 3-6-8, 3-9-5, or 2-6-9. So there's 3 possibilities for 17 for 0 mod 3 matched with 2 mod 3. Doubled 0 mod 3, I should say. Okay, what about 16? 16, you have 1 6, so double 1 mod 3. You don't have 1 4 again, so it must be 1 7 8 or 4 7 5. For 2 mod 3, double 2 mod 3 to add up to 16, you have 2 5 9, 2 8 6, and 5 8 3. For 0 mod 3, you have 3 6 7, 3 9 4, or 1 6 9. So you have one more possibility for the 16s. Interesting. Is that right? Let me just double check. Okay. To add up to 17. With 1 mod 3, 1 4 doesn't work. That only adds up to 5. So you have 1 7 9 and 4 7 6. Double 2 mod 3s. 2 and 5 doesn't work because that adds up to 7. And then the remaining digit would be 10, which is not a digit. So you have 2 7 8 and 4 5 8. And for 0 mod 3s, those are fine. To add up to 16, you again cannot have 1 and 4 together because that adds up to 5. 2 and 5, however, does work because you could have 2 5 9. And then the 0 mod 3s are still fine. Okay. These double greens are missing. This double green's missing this digit. This double green is missing that digit. And it's double green with pink. So these two are missing the same digit. This one could be a different digit. Okay, so this green. Oh. Hold up. No. That's wrong. This green is on this set. Interesting. Because it cannot be either of these. This must match this cell here, then. Huh. Okay. So this green cannot be these two. It must be the same as that. So let's mark those as letters. So we have, this is, we're going to mark this as A, B, and C. So this is A. A definitely has to be one of these two. A cannot be here, so A is here. A cannot be here. But it could be either of these two. A can't be here. A is definitely one of these. A is also one of these two. A can't be here. 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 A is one of those two. B and C, we don't know. This has to contain B and C. So really, the A is the only important one that we have information on. Okay. This contains A. This is B and C. So this is a different pink than this one. Well, does it really have to be? I think it does, right? What if we have three of them? We know A's here, A's here, A's here. So A is with double orange. A is with a double green and a pink. Do we have any other information? X, Y, and Z? I don't know. Let's do D, E, F. D, E, F. So this must be D here. This is E or F. One of these is D. D cannot be here. F is here, so F can't be here. F has to be one of these two, which means this can't be F. It's D or E here. So F is here, which means F has to be one of those two. This can't be F. We have A here, B and C. This is some A, B, C combination. This is B or C. This is obviously B or C. This is B or C. This is D or E. This we don't know. This we don't know. This is D, so none of these can be D. That's not helpful. What? Okay, G, H, and I. Let's make this G, H, and I. So therefore, this must be I here. This must specifically be H and I. That's interesting. So this is G. This is H or I. This is H or I. This must be G with H or I. G is one of these two. G and H, I makes this, so this can't be I. This is H, which means this can't be H. That's I. Interesting. So we know, okay, so A is here. So we'll have A here, A here. This is A. We're making a B, C, D, E, F, G, H, and I. So this is I here. This is then H because it cannot be G because that's G. So this is H, which makes this I. This can't be I. It's G or H. This is G, H, or I. This has to be H. So this is H, which means this cannot be H here. So this is G or I. This has to be G, H, or I here. So H is one of these two. This can't be I, so this is G, or H cannot be H, so this is G, which makes this H. So no H here. This is G or I and G or I there. Therefore, this is H here. This cannot be H, obviously. So this is GI as a pair, which means this can't be I. This is H. This is I. This is G or I here. We have two of these are G and I, but we don't know which. This is D. So this is E or F. We have E or F here. E or F here. So the H and I's are interesting. This is G and H. G and H. I cannot be here. This it's G, H, or I. This is G, H, or I. So we know H has to be one of these two. H can't be here. H is one of these four, which is not helpful. We know the other G and I's here. Oh, that's interesting. The other G and I is here. Huh. That is interesting. So both G and I add up to this sum here. Which is 16 or 17. We have B and C here. And this is B or C here. This is obviously D, E, or F. D, E, or F. Remaining cells in column 3. We have D, E, A. So A, B, D, and E. And it cannot be both D and E here. One of these has to be A or B. This is A or B, or D or E here. Okay. So we have E, F, and G adding up to the sum. I, H, and A adding up to the sum. This must be BC and this pink, this is E and F. Wait, how do we know this is E or F? Why can't that be D? I think that could also be D. We have D, E, F here, D, E, F here. This is D, E, F. We have D, E, F. D, E, F. G, I as a pair. This is B or C. We have A, B, or C there. This is B and C. And we could have D, E, F or there. This cannot be D. If this is D, yeah, so therefore this has to be D here. If this is D, it's guaranteed to have B or C with it, but it doesn't have A. And A and the other B or C are not equal values, but we're keeping D and the other B, C, which means this cannot be D. So this is E and F with it. This has to be E and F, which forces this to be D. This can't be F because F has to be one of those. So this must be D and E, adding up to some. D and E, again, if this were G here, E, F, and G add up to a sum, but D and F are not the same digit. So therefore, D and E cannot add up with G. This must be I, which makes this G, which makes this I. This is then H and G as a pair. H and G as a pair is not going to have A with it, so this cannot be A here. So this is B or C with it, which means where is A in row 8? It has to be one of these two, so this cannot be A here. This is B or C. This is A. A and D could be here. This is not E, though. We know that can't be E. This can't be E. Therefore, this is E here, which means E cannot be here. E has to be one of these two. It could technically be F and A. We are not certain. This is A, B, and D. So this can't be B. Can it? No, if this is B, this would be C. There would be no place for A in this box, so this can't be B. Which means one of these is B, which means this can't be... Well, this can't be B, this can't... One of these is B, so this can't be B. This is C, which makes that B. This can't be B, that's C. This is A or C. This is A or B. This is A or C. So this has to be C with A, and it could be D or F. We're not sure which. C is here. This can't be C, obviously. Remaining digits here. We have G and I. And either A or F. So G, I, A, F, A, F, G, I. No I here. So one of these two was I. Remaining digits of row 3 are GI, EF. Obviously, this can't be I here. Remaining digits here. One of this is E or F, and we have AB with E or F. Well, where's D? D has to be here. So this is D. This is GH. D is either one of these. So this is D, E, or F. Okay. This is C and A. Um, if this is F, if this is F, A, and C, that means um, if this is F, that's interesting. D has to be one of these three. If this is F, that means A is guaranteed to be here. A would be parts of three different values adding up to the sum. This is G and H added together. Oh, that's interesting. G, This is E, so this cannot be E here, no E here. This is D, E, that's F, which means this cannot be F. This can't be F. This has to be F here. So no E, this is F, which eliminates F here. This is E, that's F, which eliminates F here. E eliminates E here, so that's D, which makes this F. D eliminates D here, that's E. This can't be F, that's D. So D cannot be here. D is one of these two. This cannot be D. E is here. So this is E, G, and I. F cannot be here. So F is one of these three. Okay. Hmm. Um, hmm. This is interesting. Hmm. So obviously this could be the same as this, right? You have D, A, and C, then this would be D, A, and C. Um, what happens if this is F? If this were F, so if we have F here, that's D, this is EF as a pair. This would have to be A. We'd have B and D there. So this would not be F, this would be A, G, and I. A, F, and C add up to the sum. So A, C, and D can't, so this must be A and B, which would make this C. This would be A, that's C, B. So this would be C, G, and H. No C here, that's G and H. Well, we already knew that. So this can't be B and C here, it's G or H. We already knew that. I cannot be here or here, so I is one of these three. That's not helpful. So again, let's what happens if this is F. If this is F, this is D. We have A there. No A here. This can't be F. This is E and F as a pair. We know A, C, and F add up to the sum. A, C, and D cannot. So this would be A and B, which means this can't be B. That's C. This is B. This is A. That's C, which makes that A. No A here. This is then C, G, H, adding up to the sum, which makes this B. This is C. And we have a contradiction because we'd have BCF and ACF adding up to the same sum when we know A and B are different. So that cannot work, which means this can't be F. So this has to be A. So this is A, which means this can't be A here. This is A and C. That forces this to be, this can't be F, so F has to be here. That's D. So this is not pink, this is green, this is not green, that's pink, which eliminates pink here and pink here. This is double green. So this is orange and pink here, and orange and pink here. So no D here, no D here. This is D and E as a pair, and this can't be D because of D in the row, so that's E. This is D. F can't be here, it's green. F has to be one of these two. Oh, that's interesting. So A, C, and D, which means this can't be B here. This is A, C, and D. This can't be C. It's B, which makes that C, which makes that B. This is C, so no C here. So this is B, G, and H. B is one of these, so B cannot be here. This is one of these is A. So since one of these is A, C eliminates C here, so that's A, that's C. This can't be A, it's B. So we have C here. A, E, and F, B, G, and H here. F, G, I with A or B. So, what is orange? There's two oranges adding up to the sum, and there's one each of the others. So that means orange must be 1 or 2 mod 3. But we don't know because we don't know if it adds up to 16 or 17. Oh boy. We just know orange cannot be 0 mod 3. Okay. Okay. I guess we can clear this. Remaining digits of row 1. We have not very, we don't have very much. A, B, C, no D, E, F, G, H, no I. Okay, remaining digits of row, do we eliminate? No, let's keep going. Remaining digits of row 5, B, C, no D, E, F, G, no H, I. And remaining digits of row 6. We have A, B, no C, D, no E, F, G, H, I. We can eliminate B in this column. We can eliminate C in this column. We can eliminate D in this column. And it's specifically G, H, or I because it's orange. A can't be here because of... Aha! So where is A in column 4? It has to be in a green potential cell, so it has to be here. So this is A, which means this can't be pink. This is green, which means this can't be green, that's pink, which means this can't be green, it's pink, which means this can't be pink, it's green. So this is G, B, or C here. This is A, which means this can't be A, this is E, and therefore this is F. Okay, that's good. E eliminates E here, so that's G, which is not pink, it's green. So these can't be orange. Sorry, it's not green, it's orange. This can't be... Hold up. Yeah, so this is orange. That's not helpful. Okay, never mind. G eliminates G from being here, so that's B or H. There's no G in the rest of the column. F cannot be in the rest of this column. H cannot be here either. This is not B or C, it's G or I. We have a GI pair. This has to be F as in pink, which eliminates F in the rest of the box. And yeah. This can't be G, it's E or I. This can't be G because it's G in the box. E is one of these two. That doesn't help us much. No I here because of I in the column. And no D here because of D in the column. Where is D? D can't be here, here, or here. So D has to be here, which makes that pink. That gives us 3 pinks in column 5. So this cannot be pink. It's green or orange. So this cannot be E. It's A, B, C, or H. Okay. This is D. Okay, so we know orange cannot be 0 mod 3. Because we have 2 0 mod 3s, we would have to have all of these adding up to 0 mod 3 because we have 1 1 mod 3, 1 2 mod 3, and 2 0 mod 3s if that were the case. So that doesn't work. So orange cannot be 0 mod 3. Pink cannot be 0 mod 3 because we have 2 pinks not on the region sum line. And we know 3 and 6 have to be on the region sum line. So neither orange nor pink are 0 mod 3. Therefore, green is 0 mod 3. And green has to be 0 mod 3. We'll use blue for that. So this is blue. So this is 3, 6, and 9 then. Okay. What else do we have then? We have A, B, C, H, E, G, H, I, and a lot. This can't be H, right? So this has to be a 9 here. So this is 9 no matter what. This is then 3 and 6 here. So A is 3 or 6. That's interesting. Which means 9 has to be here. So one of these is 9. So we add up to 16 would be 3, 4, and 9. Or 6, 1, and 9. But the orange matches the set. Right. The orange matches the sum number. That doesn't work. Huh. Right, because this is 2 blues and a pink. Huh. That's problematic. So I must have messed up somewhere. Oh boy. I don't know where I messed up. Right. Oh, that's not good. That's not good. It has to be 1, 2, 3, 6. Oh boy. Okay, so how did I mess this up is kind of the question. Oh boy. Okay. Let's color it again. Oh boy. That kind of sucks. Yeah. Well, I mean, it happens, but it's still annoying when it does. You have so much momentum, and then you realize you got yourself into a contradiction. This is green. There's one each of these, so we have pink and orange, which means this is orange here. You're missing a green, so this is still the same, right? You can't have 15 because then these would be the same digit. Because all of these are the same. This adds up to 45, but this must add up to 45, so therefore these are the same digits, so it cannot be 15. Can be 16. The most you can have difference is 9 with 2 through 9 here. And that's 53 only, which is not divisible by 3, and this must be divisible by 3. So therefore, it's 16 or 17. And this has to be green, because this must be... We're losing that, but we must gain that same modulo, 3. You can't have orange and pink here, because then that would add up to 0 modulo 3. So this is... cannot be double pink, so this must be double orange, which makes this pink. We're losing an orange here, and we're gaining an orange, so we must be losing a pink and gaining a pink. These can't be orange. We cannot have green and pink here for the same reasoning. So there's double pink, which makes that green. One of these is green, so this cannot be green. So this is pink, which makes that double green. This cannot be double green. And it can't be green and orange. So this must be green. This can't be double orange. This is definitely pink here. So we have one pink here, which means one pink is here. We cannot have green and orange here. So we're guaranteed a pink here. This has to be double pink, so this can't be double pink. That's green or orange, which means pink has to be one of those two. This is then green or orange because we have 3 pinks already in column. We have 3 pinks and 3 greens in column 7, so this is orange. This cannot be double orange, so this must be double green here. Therefore, this is green, pink, and orange here, which means this can't be orange. That's green. This is then double green and pink. This must be double pink and 1 orange. This cannot have double pink or double orange, so it must be double green. We have double green and either orange or pink. This is pink or orange. We have double green here because it can't be double pink or double orange here. Can't be 3 of the same set. Yeah, you can never have 3 of the same set because 1 modulo 3 plus 1 modulo 3 plus 1 modulo 3 will have a sum of 0 modulo 3. 2 modulo 3, 2 modulo 3, 2 modulo 3 has a sum of 0 modulo 3, and so does 0 modulo 3. So this must be double green here, which means this can't be double green. This is pink or orange. We have 5 pink and oranges here. And one of these must be pink or orange. So that's 6 pinks and oranges, which means the rest are green. So one of these is green with the pink or orange, which means one of these is green with the pink or orange. So this is green. One of those is green here. We cannot have double pink here. And it can't have double green here because one of the greens is here. So that means one of these is green, which means this is green with double orange. So that eliminates orange from the rest of the box. So this is pink, which means that can't be orange. That's pink, which means it can't be pink. That's orange. We are losing a green here and gaining a green here. So that's net 0. Therefore, we must be losing a pink here and gaining a pink here. So that's pink, which means this can't be pink. That's orange. We have double orange here, so this rest cannot be orange. Therefore, it's green and double green and pink here. This can't be pink then, so that's orange. This is green and pink, so this can't be orange. So this is orange there. We have 6 cells, which are green and pink. And in fact, we have 3 pinks here, so this can't be pink here. That's green. So that leaves these as orange. So now we are in the labeling. So we're going to try A, B, C. This was D, E, and F. This is not pink. So this is orange because of the 3 pinks in the box. This can't be orange. This must be, we had this G, this H, and this I. So G, H, and I. This is B and C. We have A, B, C here. This is B and C. This is A here. So A cannot be here because these are the only green cells. So A is here. Therefore, A is there. Also, A eliminates all possibility for A. A has to be there. This is D. Okay, this must be I. This is specifically H and I. That forces this to be G. So this is H. This has to be H or I. This has to be H or I. Cannot be I because of I in the row. So this is H. This is I. We have this as GI as a pair, which eliminates GI and the rest of the column. So this can't be I. That's H, which makes this I. So this is GH here. GH here. GHI. GI here. GH here. This can't be H or I, so this is G, which means this can't be G, that's H. So then we have G and I here. Oh, this doesn't have to be the same set. This could be... Sorry, this can't be one... This doesn't have to be one of the same set. That's where I went wrong. Okay, so that's where I think I made the bad assumption. Let's just continue with this to see if this makes sense. A can't be either of these, so A is here. This is B or C. This is H. So this is G or I also. And we have a guaranteed H here. We have one green here, one green here, one green here. This cannot be green. So that's orange, which is G or H or I. Okay. This, we have B and C here, B and C here. D, E here. This is AC here. This is BC here. E and F, E and F, D, E, F, D, E, F, D, E, F, D, E, F. A is here, so B or C is there. We have D, E, F as possibly. This can't be D. A, B, C, A, B, C. This is B or C. D, E, F, D, E, F, D, E, F. This can't be D or E. So this is D, E, F. Remaining cells of column 3 are A, B, D, and E. Remaining cells of column 2 are A, C, F, G, and I. Okay, no I here. This is D, E, and F. This could be B, C with D, E, and F. But if this is D here, so that's the problem, right? So if we had D here, D would necessarily be with B or C, but we have B or C here. So two of these are the same, and then the other one's different, but they can't add up to the same sum. So this cannot be D, which means where's D in column 8? It must be here. So that's D, which means this can't be D. This is D plus another digit. It could be E or F, but F is here. F can't be here. F can't be here. F is one of these, so this can't be F. This is E, which makes that F. So no E here, no F here. Okay. So E cannot be here. Where is E? E cannot be here. E cannot be here. So where is E in box 7? It must be here. So this is E, which eliminates E and F here. So that's D. This can't be I, obviously, or G. No G or I. A, C, or F. This is A, B, or C. So how did I get that as F? Is the question, right? Oh, well, we know. Right. Well, we don't. Yeah, that is the question. This digit has to be the same as this. Which means it's one of these two. Um, this is E or F. This is A, B, C, E or F. Okay. This cannot be green. So this is orange or pink. Because we have a guaranteed green here, we have a green here, we have a green here. So the question is so we know A in column 4 cannot be in, has to be in the green. So it has to be one of these two. So one of these two is A, which means this can't be A here. This is guaranteed to have H with G or I. So and A cannot be here. Because A has to be one of these two cells in column 4, because it has to be in the green. These aren't green, and A can't be here, and A can't be here, so A is one of these two. So this cannot be H and I, it must be H and G. So it's H and G with B or C here, which means this can't be G. This is I here, this is G, this is I. Oh, and the same thing, we can't have E and D and ED, EDG, and EFG add up to the same sum. Okay, so I's here, right? Remaining cells of row 3, we have E, F, G, and I. Okay. No I here. These are, right? So A is one of these two. So the question is, how did I get an A there? That was kind of, yeah. This is not E or F. Um, hmm. Huh. I wonder if I messed something up here. Anyways. Right, we are guaranteed 2 oranges on this sum. But we don't know if the other ones are the same set. It could be 2 greens, right? Um... Hmm. Yeah, how did I get this as A? That's maybe that was maybe the main question, right? Hmm. Well, we know this includes A. Well, the thing is, so what I was doing was I had F, A, and C, but we're not guaranteed that this has to be A and this. We're not guaranteed this has to be F, right? Okay, remaining digits of. Ugh. So this has to be no D. It's E, F, G, H, no I. Okay. Column. These are pink and orange. Remaining digits of row 4 are A, B, C, D, E, F, G, H. And this could be all of them. A, B, C, A through I. No H here, no H here. No D here, no D here. This can't be I. Okay. Okay. So what happens if this is F? If this is F, this has to be A in some sort of combination, but it cannot be the same combination as this. So then, cannot be F, B, and C adding up together. So this would be D. No D here, no D here. So this cannot be F, which would force this to be B, C, E, which would mean this can't be E, that's F, which makes this can't be F, that's E. So BCE eliminates E there, so that's D. This is not D, that's F. This can't be F, that's E, that's F. So this can't be E or F. It must be D here. So this is D, which means this cannot be A. So this is E or F. And this is B or C with B or C. So no green, no pink, no green, no pink. Therefore, this would be A. So that's potentially possible. That means this can't be A here, which means A has to be here. That's C. So then this would be A, C, and F. So this cannot be A, C, and D, which means this is A, B, and D. Which means this can't be B, that's C, which makes that B, which makes that C. So far this is looking okay. C eliminates C here, so that's B, which makes that C, which makes that C and B. So this cannot be B, it's C, G, and H. Therefore, that's B here. No B here, A, that's B. So no B here, no D here, no B or D here. So that's looking okay. No C or F, no C or F. This is A, G, I. This can't be A or E, no A or E, it's B or D. So that's fine. Huh. D can't be here. This is B, that's D. So this is green. This cannot be green. It's pink. This cannot be pink. It's green. So this is B. This is E. No E here. No C here. So one of these is F. Okay. No E here. This is FGI, which makes this D. This is E. No E here. I mean, so far this is looking fine. Yeah, I don't know how I eliminated this A. That might have been also the problem too. Anyways, G, H, or I. D is pink. So we do have a pink, a green, and two oranges here. So then orange cannot be 0 mod 3. Okay. A cannot be here. A has to be one of these two digits. So A must be 1 through 6 in this scenario. H eliminates H here. Yeah, this is actually looking like a potential solution. Maybe we go the other way and see if that does lead to a contradiction. Okay. Let's try that. So that's when we made this F. So what happens if this is D? If this is D, this becomes an AC pair. So this is both green, which means this is orange and pink. And this must be not green, so this must be a green pair. Nope, we have the same thing. So that's actually interesting. Orange can never be 0 mod 3. Because in both scenarios, we have one pink, one green on this sum, and two oranges. If orange were 0 mod 3, then the sum would add up to 0 mod 3, which is not allowed. So we have D here. This is F. This is AC as a pair, so no AC here, no AC here. This is not D or E, it's A or B. So this is FGI, no FGI here. This is D. This is AC as a pair with D. This can't, then that must be AC here. So this can't be C. It's B. That eliminates B from the rest of the column. Does that help? I don't know. We could have BCF here now still. We don't know. A is still one of those two. Hmm. So this is BC as a pair. Oh, so basically we've gotten this as C both times. Um, because A has to be one of these two, cannot be here. So therefore A can't be here, A can't be here. So where's A in row 8? It has to be here. Right, so either way, okay, so that's interesting. Right. So that we should be able to get the deuce anyways then. So where is A in row 8? Again, in A in column 4 can't be any of these. This can't be A because of A in the row. This can't be A because of A in the row. And these are not green. So A has to be one of these two, which means A cannot be here. Whereas A in row 8, it has to be one of these two, which means this cannot be A. This is guaranteed to be C. So that eliminates C from the rest of the... Oh, that's interesting. That eliminates C from the rest of the column and box. So this can't be C. This is B, which makes that C. This can't be B then. So B cannot be either of these. This is AC as a pair. This cannot be C. We have D, A, and F as a triplet here. Well, that's fine. C eliminates C from being here or here. E cannot be either of these. So B is one of these two. Interesting. So I don't think that changes very much. This can't be C, this can't be C. So we still don't know if this is B, C, and F or B, C, and E. So that still hasn't changed. Okay. Um... So do we go about testing if it's D? Okay. Maybe. So what happens if this is D? If this is D, this is A, this is F. No F here. No D here. It's A and B. No A here. This is F, G, and I. So again, no pink here, no green here. These are both green. These are pink or orange. So C is here. This is AC. Well, we know this already, so that's fine. This cannot be C. So A, C, and D add up to the same sum. So this is A, C, and D. This can't be C, that's B. No B here, no B here. What else do we have? Hmm. Yeah, we get orange cannot be 0 mod 3s. This can't be H because of H in the column. We can remove that anyways. Um, oh. Either way, if this is F, so what happens if this is F? Okay, so let's do that. F, D, no D, no F here, A, G, I. This is A, B, and D with A there. So I think we came up with that this was also a set of 3 digits and 2 oranges, right? So this is green and orange. And this is B or D. This can't be pink, that's green. A, F, and C add up to the sum. So this cannot be A and C and D. It's A, B, and D. So therefore, this is C, this is A, that's C, which makes that B and A. A cannot be here. This is B here. No C here. So it cannot be CF and B here adding up to the same sum. So it must be CF and BC and E. So this can't be E, it's D, which makes this E. That makes that F and D. This is F, that's E. No E here. No F here. It's B, C, and E. We have BD as a pair. But D eliminates D here. So that's B, which makes that D, which means we do have 2 oranges. Cannot be the 0 mod 3. And they must add up to the sum mod 3. Which means an orange with 2 other digits must be with the 2 other digits must be, or actually if you have 2 oranges added together, they cannot add up with a 0 mod 3 because the orange plus 0 mod 3 is the sum. And you have 2 oranges, that's not going to be the same as this one extra orange mod 3. So that means green cannot be 0 mod 3 either, which means pink has to be the 0 mod 3. Either way. So we've shown that both of those work, or both of those go into that situation. So whether it's FAC or ACD as the sum, they both will force... They will both force this sum to be 2 greens, a pink, and a green. Sorry, 2 oranges, a pink, and a green. So therefore, the orange matches the sum mod 3, which means pink has to be 0 mod 3. So pink has to be the blue. Okay. Huh. Okay. So what is this sum is actually kind of interesting then. So this cannot be blue here. So we know blue is one of these two. This is then green or orange. Um, these are green or blue. And these are green or orange. Or blue. Okay. So this cannot be D, E, or F. That's interesting. Um, okay. Huh. What are the sums again? I have to think through those sums again. Um, hmm. 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 What are the blues that add up to the double blues that add up to these sums? It's E and F and D and E. Um, can E be a 9? Well, yes, certainly. Can E be a 3 is kind of a question. Yeah, it could be 3. 3, 6, 7. Hmm. We have guaranteed G and I here. Okay. Interesting. A is part of two doubles, at least. Can it be part of three doubles? Or, well, that's not a good way of putting it. Um, hmm. Can we have this be AC AB and BC here. Without AB and C being 0 mod 3. Yes, if it's 16, right? Um, so if this is F and G, that means whatever these digits are. So if this is F and G, that means this is DE as a pair. This would be A or B with I. A, B, and I would have to add up to E. Okay. If this is A, G, and I, that means it would have to be this is F, this is D. So none of these could be D. This would have to be D. So then D, D and G would have to add up to H. Okay. Hmm. This cannot. Okay. So if we have F, C, and A, I mean, it's possible. Oh. Okay. F, C, and A. And the greens are not. So if you have FCA here, you have to have this be a different set because it cannot be A and C here. It's B and C here. And you can't have D with A and C here if this is F, C, and A. So this must be D, A, B. So these have to be three separate sets adding up to the same sum. And therefore it would have to be 2 mod 3 for the greens if that were the case. Because you 1 mod 3s can never have three distinctly different sets adding up to their sum. But we have a contradiction there because this must be essentially if this is 3 greens, three double green sets, it must be 2 mod 3, which means orange is 1 mod 3. Oh, actually, that's not a contradiction, is it? That's the only scenario where it could work. Huh. Dang it. Okay, I was hoping that would lead to a contradiction. Because the thing is, that would simplify things a lot. But I think we have to go deeper, unfortunately, into this. Right. Okay. Um, hmm. Say it was 17. That means we have to have. If it's 17, orange has to be 2 mod 3. So green is 1 mod 3. And we only have two possible sets adding up to the sum of 17. So then, what would that be? Then this would have to be A, C, and D. So you would have to have A, C, and D. And so this would be non-green, non-blue. This would not be green. So this would not be blue. We have double green here. No D here, no D here. D eliminates D here. That's F, which means this can't be F. So we have F, G, and I here with A and B. We could have a wide variety of things here. The problem is this is the least restrictive, so I'm assuming that this actually probably is the correct path. This would then be A, C, D. This would be B. Yeah, it's not restrictive enough, I feel. So let's again try this path. So this is F. F, D, A. No blue. So no A here. No F here. No D here. That's E, F as a pair. D, F, A, and C add up to the sum. So this cannot be A and C. It's A and B and D, which means this can't be B. This is C, which makes this A, which makes that C, that B, that A. So no A here, no C here. This cannot be B, C, and F adding up to the same sum as A, C, and F. So this is B, C, and E, which eliminates B, C, and E in the rest of the box. So this is D, that's E, which makes this F, that's D, that's F. No F here, that's E, this is F. So this can't be E or F, that's B, which makes this D. So this is not blue, not green, which means this is not green, this is not blue. So this has to be B and B. This can't be B, it's C, G, and H. This is E, F as a pair. B eliminates B here, that's C. So no C here. D eliminates D here, so that's B, which makes that D. No blue, no green. No green, because this can't be B. It's E, which means this can't be E. It's B. No blue. So no blue, no B here. No F here. No D here. No B here. No B here. No E here. Okay, B cannot be here. This is A, which means this can't be A. That's B. So no A here. This is now GH as a pair, which means this cannot be, this is not green. So this has to be I. So this can't be I. That's G. This is I. This is H. This is G. That's H. This cannot be orange. So no orange here. So wait. This can't be orange because of the remaining cells in the box. We have 3 oranges. No G and H here. This is E. No E, G, H. That's C. No E, C, G. That's A. No G and I. No A. That's F. So this has to be A here. That's G. So that's how that would work. So no blue. No green. That's orange. No orange or blue. That's green. This is blue. A is green. This is green also. No H here, so this must be H here. That leaves this as G, not blue. So E means this can't be E. That's F, which means this is E. No G here. That's C. So no orange. No green. That's G. This can't be G. It's E and F as a pair. So this is F. That's E. This would be B. This is not orange. So this has to be orange here. So far, this is looking okay. So this is C. So that would be that scenario. D would obviously have to be 9. So this would be 9. It has to add up to 16 because the greens are the 2 mod 3s. So this would A and B would have to be 2 and 5, which means C would have to be 8. Okay. G and H would have to be 1 and 7 to add up to 16, so I would be 4. And we have a, well, do we have a contradiction? We do have a contradiction. Because you have to add up to 16. It's 1, 2, 3, 4, 6. Okay. And yeah, and we have 8 here and 4 here, and that obviously doesn't work. So that's the contradiction, which is why F doesn't work there. Okay. This is convoluted, man. Man, you had to go down the long path to show that. That's, I don't know. Not easy. Not easy. So this cannot be F. Which means this is A. So not blue. This is A. This cannot be blue, green because there's no more A left. This is F, G, and I. A eliminates A here, so that's D, which eliminates D here, so that's F, so there's no F here. Therefore, that D eliminates D here. These are both green. So no green here, that's blue. Okay, now how do we solve this? So this is C, A, and D. This must be C, A, and D. So this can't be C, it's B, which makes that C. No C here. This is B, G, and H adding up, which means this can't be B. C eliminates C here, so it's A and B. This can't be A, so that's C, which means this must be A here. There's no other place for it. C can't be C there, so that's B. B eliminates B here, so that's C. So this is green, no blue. So this can't be green here. This can't be green here. Those are both blue. This cannot be blue. It's green. So this is B and C. This cannot be B or C. It's E and F. This EF, we have an EF pair in column 5, which eliminates E and F in the rest of the column. This can't be E or F. It's G. So no blue there. That eliminates G from the rest of the box or row. Also column. No G here, no G here. Okay. Here, we are guaranteed 2 blues and 1 of each of the other sets. So that means we must be having... So 2 blues is 0 mod 3. 1 each of the other sets is 0 mod 3, which means we have one extra, and it cannot be blue. So it must match this set here, which is orange. So now we have 2 oranges and 1 green here, which means these can't be then orange. This has to be green. Because this sum mod 3 must add up to the same this sum mod 3. Well, we have 1 extra orange. This must have 1 extra orange. And we have guaranteed 2 blues and 1 each of the sets. So then the extra 1 must be an orange, which means this is green. That's AB as a pair. This cannot be green. It's blue. Therefore, this can't be blue here. This is green. So we have a green triplet in column 5. This can't be green. This is orange, which means this can't be orange. That's green. So this is H. This is G. No G here. No G here. No H here. This can't be A, B, or C. And this can't be H. So this is D, E, F, which is a blue. H is one of these two. We don't know which. This is D, E, and F. This can't be B. This can't be A or B because of the AB pair in the row. This is blue or orange. I'm not sure which. And where is the green? Can't be here. Can't be here. Must be here. So this is A, B, and C. Okay. This is 9. So no matter what, this is 9. D cannot be 9. So one of these two is 9 here. This can't be 9. This could be 9. So one of these is guaranteed to be 9 here. Okay. This is 3 or 6. Can this ever be 9 here? These two must add up to the other one. Yeah, you could. Can this not be 9? Maybe that's a better question. Well, maybe not. This is definitely 9. We have 3 or 6 here. What we have here then is F and G. So either A and B with I adds up to E. Well, no. A and B with I adds up to E, guaranteed. Because F and G are the same here. That's the same sum as that. We have I and H, G and H. Oh, this is B. This has to be B, so there's no B here. It's not helpful. So maybe we still need this 9. So in that scenario, if this is A, that's A and I, so then F and G would have to add up to H. Okay. What we do know is DE adds up to the same as AH. Okay. We know B is not in the sum. Guaranteed. G is in the sum. Guaranteed. So G has to be 1 through 6. So G is 1 through 6. D is also... Okay, where is D? Right. D cannot be in... So where is D? D can't be either of these cells. D can't be here. D can't be here. So D has to be here. Okay, so this is D, which makes this E, which makes that D. So that's helpful. D eliminates D here, so that's F, which means this can't be F. That's E. F eliminates F here. So this makes things much easier. So that's D, that's E, that's D. This can't be F, that's E. So B, C, and E still add up to the sum. Interesting. E eliminates E here, so it's F, that's E. So E's here, which means this can't be E here. No E here. Okay. This can't be E. So F is one of these two. E eliminates E here, so that's F, which makes that E. Okay. So E is 9. That's helpful. So we know that's 9. B and C add up to whatever this is. So it's going to be either... so this is 9. We do not have a 9 here. Okay. So that means A and B with I adds up to 9. Okay. D and F are 3 and 6. Okay. D and I. Okay. D and I add up to 7 or 8. So does F and G. B and C also add up to 7 or 8. Okay. Okay, so if B and C add up to 8, they must be 1 and 7 because they are not the correct modular of the sum. So if they add up to 8, it's 1 and 7. If they add up to 7, it has to be 2 and 5 here. So A has to be 4 or 8. Interesting. So this is A. These are A, B, and C. A, C, and D could be 3, 5, and 8. Or 6, 4, and 7. A, C, and D. So A, B, and I adds up to 9. D, I, and F, G add up to either 7 or 8. Okay. So DI and GF add up to the same sum. I and G are the same mod as the sum. So one of these is 3 and one of these is 6. If they're the same sum, it's 2 and 5 with it, or 1 and 4. So G is 1, 2, 4, 5. Obviously, F is 3 and 6. Oops. 3 and 6. D is 3 and 6. So I is also 1, 2, 4, 5. Ah, that tells us something. Okay, so I is 1, 2, 4, 5, right? Because it's either 1, 6, and 3, 4 adding up to 7, or it's 2, 6, and 3, 5 adding up to 8. So that means H is guaranteed to be 7 or 8. So this is 7 or 8 here for the H. So H can never be here. Because if H is here, H is guaranteed to be 7 or 8, but again, we can't have to add up to the sum. It must be 1, 2, 3, 4, 6, or 1, 2, 3, 5, 6. Because we cannot have, we have one of each set here. So this cannot be H, which means this is F. So this is F, which makes this I. That makes this F. So this is not orange. This is blue, which eliminates blue in the rest of the row. This is G. This is I. This is F. So no I there. That's G. This can't be F or G. This has to be I, which makes this H. No blue here. No blue here. No orange here. This is not H. This is G, which makes this H. So again, the G's are also 1, 2, 4, 5. The I's are 1, 2, 4, 5. And this is not blue. This is orange. This can't be orange. That's blue. So F's are the 3 and 6s. H's are the 7s and 8s. Okay. These are H's. Oh, I forgot to do the H and I's. Okay, well, this is G. So this is G. This is I here. These are both I. This is G. This is I. This was F. 3, 6, and they're F. This was F. This is D. This is D. That's F. This is D. That's F. This is D. That's F. D and F. F and D. F and D. D and F. D. Okay. G and I. G, H, I. So this is H, I, G. This is G, H, I, which makes this G. This is I. This is G. This is I. And this is G. G and I. Wait, that doesn't work. Wait. Isn't that a contradiction? This is I? No, this can't be G. That's why. This is not G. This is I here. This is G, which makes this I, which makes that G. There we go. And this is I, and this is G. That's G there. Okay. A and B. So this is definitely adding up to... So this is G and I. Can you have 1 and 4 here? Maybe? 2 and 5 would add up, so it's 17. So then this would have to be... this is 3 and 6. This is 7 and 8. This is essentially 4, 5, and 7 and 8. So this has to be 1 or 2 here. B is always going to be 4, 5, 7, 8 as possibilities. So these are B. We have 4, 5, 7, 8 because it's one of these two. C are here. So this is G and I, G and I, G and I, G and I. Obviously, G and I never add up with each other. To add up with another digit to add up to the sum. These must add up to a 0 mod 3. Because we have to have the remainder be a 1 mod 3. So if this is 7 and 8, this must be 1. So we have either this 7 and that's 8, which makes that 1. If this is 4, this is 8. That's 12, which makes that 5. So I is 1 or 5. Which means G must be 2 or 4. Okay. Um, hmm. Can this ever be 3? Well, this would have to be 6 then, if that's the case. Okay, what? B is one of these two. And in that scenario, it can't be 1 or 2. It's 5 or 7. So B always has to be 5 or 7. So A is 4, 8. B is 5 or 7, which means C has to be 1 or 2. So this is C, which means this can't be C here. This is A. This can't be A here. That's C. So we have C here. This is A here. That's B. So A is 4 or 8. So this can't be A. This is B, which means this can't be B. That's A, which means this can't be A. That's B. So we have B here, and this can't be B. This is A. So now we should have everything set up. A is 4 or 8. B is 5 or 7. So the question is, how does this add up? 2, 5. So G and F add up to 6 or 7. A and I add up to 9 no matter what. Okay. This is C, so this cannot be C. This is B. This is C. So we have B here. This is C. Oh boy. 8 here requires this to be 7, and that's 2. 7 here requires this to be 5, and that's 4. We don't have anything that differentiates these. That's crazy. Huh. A and F. A must be equal to C plus D. We have F, G, and I here. F, G, and I here. A is then equal to the same sum as C and D. Therefore, A and C and D are the same sum. So they must add up to an even number, which is not 17. So it is 16. So then I has to be 1 mod 3. All the oranges are 1 mod 3. So I's are 1. G's are 4. Ugh. G's are 4. F's must be 3. And D's must be 6. So C is 2. A is 8. We have 2, 5. So B is 5. And H is 7. Woo! That was crazy. That was, wow. Very cool logic. Very difficult to execute. The logic was very cool. It was very difficult to execute. Even to the end, I was still not sure whether this was 1 mod 3 or 2 mod 3 for the oranges. Yeah, I made a mistake somewhere here where I set one of these equal to F when it couldn't be, or D when it couldn't be, and that changed everything there. So that's when I made a mistake there. But the logic behind it actually was very solid throughout, so it was interesting. Very cool. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.